Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 19, Unknown Area Problems on the Coordinate Plane. Okay, so this is a classwork, and it's an example on area of a parallelogram. The coordinate plane below contains figure P, and it's parallelogram ABCD. Take a few moments to answer these questions, A, B, C, and D, about this diagram. Pause the video, come back and check your answers. Okay, hopefully you were able to do these activities on your own. Now let's check your answers. A says to write the ordered pairs of each of the vertices next to the vertex points. So A is here, and to get to A I went left 3, that's my x value, negative 3, because it's on the x-axis, left 3. The y value is down 4, which is negative 4. So A is negative 3, negative 4. B is 0. I didn't move left or right, so x is 0, comma, I went up to 0, 2. To get to C, I start at 0 and count over 1, 2, 3, 4, 5. So that's x equals 5. And then I went up 2, so y is 2. And then finally, D is over 2, to the right 2, I'm where D is, so x is 2, and then down 1, 2, 3, 4, negative. So I have 0, 2, 5, 2, 2, negative 4, negative 3. Now B says to draw a rectangle surrounding figure P that has a vertex point of A and C. So we're going to use these corners as our vertex points of our rectangle. So I'm going to be neat about this. I'm going to bring in my ruler. Okay. And I'm going to rotate it 90 degrees, and I'm going to line it up with A. Choose green for this. So I'm going to start at A. I'm going to draw up until I get to the height of B and C, which is there. Now move over to C here, draw a line from C down to D. Rotate this back to 0 degrees. And what I'm doing is I'm continuing this line over here, and then come down here and do the same thing. Okay. This point here now. Alright, just cleaning this up a little. So D is 0.2, negative 4. So there's my rectangle I created around it. It says label the two triangles in the figure as S and T. So P is here. So we'll call this triangle up here S, and this triangle down here T. Use black. So this is S, and this is T. Okay, so part B is done. Now it says find the area of the rectangle. So whenever we're given a problem with formulas, we should always write the formula. So I'm going to write the area of a rectangle, which is area equals length times width, and then I substitute in my givens. The length goes from negative 3 to 0 is 3, and then from 3 to 5, now we're going all the way out to here. We're looking for the area of the rectangle. This is a distance of 5. This is a distance of 3, so the length is a total of 8. And the height goes from negative 4 to 0, which is 4, and then 0 to 2, which is 2 more, so 4 plus 2 is 6. So the area of this rectangle is 48 units squared. Okay? Part D, find the area of each triangle. Okay, so area of a triangle is 1/2 the base times the height So I'm going to write this formula twice because we're doing two triangles. So this will be area of triangle S. This will be area of triangle T. So I use a subscript letter to so we can recognize which is which. So the area of triangle S equals 1/2. So now my base is this piece right here, and that's a distance of 1, 2, 3. So my base is 3, and my height is the distance from A all the way up to here, which was 4 plus 2 for 6. So my area of S is 6 times 3 is 18 times 1/2. In other words, half of 18, 9 units squared. The area of T equals 1/2. Now if I go up here, this distance is 3. This distance is 6. Same as the other triangle. So it's just a repeat. The base 3, the height 6. So area of T equals 9 units squared. Okay? Now it says use these areas to find the area of parallelogram ABC. Alright, so what they're trying to explain to you here is we took an entire rectangle, we found the area of S and T, and this is the whole thing minus those two triangles. So what we're really doing is the area of P equals the area of the rectangle minus the area of the S triangle plus the area of the T triangle. So there's my formula. We're looking for the area of P. The area of the rectangle was, I notice that they're going from page to page again here, the same question. The area of the rectangle was 48 units. So I'm going to put 48 minus, and then the area of each triangle was 9. They were each 9. So I'm going to write area of S is 9, plus the area of T is 9. So the area of P equals 48 minus 18, because my order of operations says to do parentheses first. So I finally get my answer. The area of that P parallelogram is 30 units squared. Okay? Coordinate plane below contains figure R, a rectangle with the same base as the parallelogram above. Okay? So in other words, this has the same base as the parallelogram above. So if I go back to this parallelogram, it had a base of 1, 2, 3, 4, 5. So this rectangle has a base of 1, 2, 3, 4, 5. It says draw triangles S and T and connect figure R so that you create a rectangle that is the same size as the rectangle you created on the first coordinate plane. So if I go back and look at my diagram, I had a rectangle that had a base of 3 and a height of 6. So if I add that to this, then this would come out 3 and go up 6. And then this diagonal over here, so that would be, let's make sure they're going the same way, that would be T. Right? Okay, so we label that with black. That's T. Now if I were to do the same thing, make another triangle, flank 3, base 6 here. Now this is triangle S. Okay, here's triangle S. Okay. So I moved S from this side over here over to here. This is S. We do them in different colors. This is S right here. And T is the green one. So I put the two S's and the T's together, and then we get that whole area of 48 from this entire diagram. So what they're leading up to here is we can take and move triangles around to get a shape. So it says draw triangles S and T and connect the fingers R. So you create a rectangle the same size as the rectangle you created in the plane. That is done. It says find the area of rectangle R. Now we just do the distance of the base. So I write area equals base times height, or length times width, same thing. 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5, 6, and the area of R equals 48 units squared, which is the same as my rectangle. Okay? What do figures R and P have in common? So here's R, and here's P. What do they have in common? I would say they have the same base. Of, the base is 1, 2, 3, 4, 5. They have the same area. Of 48, not 48, 30 units squared. Okay? We're talking about R, by the way. 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6. 5 times 6 is 30. So R and P both have the same base of 5, same area of 30, so therefore the same heights of 6, because base times 6 is 30, and base is 5, height has to be 6. Okay, so now we're on to the exercises. You're given a few diagrams here, these 3 diagrams. And it says to find the area of the triangle, find the area of the quadrilateral, 2 different ways, and find the area of the quadrilateral. Or you're given the area, they want you to find the height. Okay, so try those 3 problems, pause the video, come back. Okay, hopefully you've had a chance to figure these out now. So the first thing I always do when I'm given a geometric figure is write the formula for the value they're asking for. So the area equals 1/2 base times height, and then substitute. The base is 1, 2, 3, 4, 5, 6, 7. That's length 7. And the height is 1, 2, 3, 4. So the height is 4. So the area equals. Now there's 2 different ways we can figure these. I often look for an even number in this formula, and then you can easily take half of it. Half of 4 is 2. 2 times 7 is 14. Or you can say 7 times 4 is 28, and half of 28 is 14. Either way, you'll get the same answer. So the area of this is 14 units squared. Number 2. Find the area of the quadrilateral 2 different ways. Okay? Well, here's one way I would do it. If I know that this is a triangle, right here, so the area of this triangle, this triangle here, is 1/2 base times height. So this is, I'll do these all color coded. So I'm looking at this triangle here. So the area equals 1/2. The base is 1 times the height, which is 1, 2, 3, 4, 5. So the area of that little red triangle is 5 times 1, which is 5, divided by 2, or 2.5 squared. And then I can make a triangle here. Okay. See that triangle there? Right here. So area equals 1/2. The base is 2. The height is, again, 5. Half of 2 is 1, so the area is 1 times 5, or simply 5 units squared. So now I found those two, but look at what it created in the center. Perfect rectangle right here, with a width of 2 and a height of 5. So the area of a rectangle is base times height, which is 2 times 5. So the area is 10 units squared. So now that I have all three areas, I can just combine them. So the total area is 2.5 plus 5 plus 10, which is 17.5 units squared. Okay. Okay, the other way to find the area of this is to use the formula for area of a trapezoid, which is what this is. By definition, a trapezoid is a four-sided figure, quadrilateral, with 2 parallel sides and 2 non-parallel sides. That is a quadrilateral trapezoid. The area of a trapezoid is 1/2 base 1 plus base 2 times the height. Okay, so this has 2 bases. This base here, I will call base 1, lowercase b, I suppose. This is base 1, and this is base 2. The height is the vertical distance, not diagonal. So there's my height. So the area equals 1/2 base 1, which is 1, 2, 3, 4, 5, plus base 2, which is 1, 2, times the height, which is 1, 2, 3, 4, 5. So there's my formula. There it is substituted in. And now I'm going to simplify. So it's 1/2 10 times 5. So the area equals half of 50, or half of 10 is 5 times 5, which comes out to be 25 units squared. Excuse me. I don't know where I got 25. Didn't sound like the one I got before. 1/2 of 10 is 5. 5 times 5 is 25. Oh, I see what I did wrong. So I made a mistake right there. I multiplied. 5 plus 2 is 7 times 5. My apologies. So 7 times 5 is 35. Half of 35 is 17.5 units squared. Hopefully you caught my mistake immediately. It took me a second, but I did catch it. So 17.5 squared. Now we are given the area of a quadrilateral again. And we know that the area is the base times the height. In this case, though, they're telling us the area is 12. So now I know A. So this is why the formula is so important. Write the formula down, substitute in the givens, and solve for what we don't know. Okay? We know that the base is 1, 2. We know the base is 2. We don't know the height. The height is x. Let me change that to 2 times x. So I plugged in the value they're using, x units. Okay? We can't really read the grid this way. They took the horizontal grid off, so you can't just simply count. So they're trying to solidify the fact that if we know the area and one of the base or the height, we can do a calculation and solve for that variable. This is multiplication. We do SAD math. In other words, we do the inverse operation to cross the equal sign. Inverse of multiplication is division. 2 divided by 2 is 1x. 12 divided by 2 is 6. So the height is 6. For 4, the area of this triangle, find the side length, and then find the area. So you have 2 more problems to do. Pause the video, see if you can do these, and come back and check your solution. Okay, let's see how we did here. The area of a triangle ABC, triangle A, B, C. So it's this triangle here. It's 14 square units. It's asking for you to find the length AC. Okay. On this diagram, if you draw a perpendicular down the side, that is our height. Height is straight down. This is not our height. Okay. This is height. This piece here, without the extension, is our base. So if I write the formula, area equals 1/2 the base times the height, then I substitute in all of my givens. Okay, the area is 14. That goes there. I don't know base, they do know the height. So they took away the x coordinates here, so you can't see them. But we can count our height. And from 0 to 4 is 4. From 0 to -3 is 3. That's a total distance of 7. So I'm going to say times 7. So this is 14 equals, well, 1/2 times 7 is 7/2. B. In order to get rid of a fraction, we multiply by its reciprocal. So I'm going to multiply by 2/7. That will cancel the 7s, that will cancel the 2s. I'm left with B. 7 will cancel with 14 and make it a 2. 2 times 2 is. So the distance from here to here is 4. So this should be 1. And that should be 3. Or 1/2, 3.5. We don't know, so I shouldn't even say that. The total distance, though, from B to C is 4. And square units, so the answer should say units. Okay. Number 5. Find the area of triangle A, B, C. So it's this triangle in here. And they surrounded it with a rectangle. We know how far it is from here to here. We know how far it is from there to here just simply by counting. So we're going to find the area of this triangle by using the rectangle. So this takes quite a bit of calculation. I need to know this region here, this region here, this region here, and this one. I can find all of those. So first thing I'm going to do is find the area of rectangle RSTA. So the area of RSTA equals base times height. The area of rectangle RSTA equals the base, which goes from -6 to 0 is 6, 0 to 5 is 5, 6 plus 5 is 11, times -4 to 0 is 0, 0 to 6 is 6, -4 to 0 is 4, I'm sorry, 0 to 6 is 6, 4 plus 6 is 10. So the area of rectangle RSTA is 110 units squared. Now we're going to find the area of triangle RBA. And that's 1/2 base times height. So the area of RBA equals the base, 1, 2, 3, 4, 5, 6. And the height is 6 plus 4 or 10. So the area of RBT is 1/2 of 6 times 10 or 60. The 1/2 of 60 is 30. Okay. And then I want to find the area of this triangle. So I'll do that here. The area of BSC equals, I want an equal sign. The area of BSC equals 1/2 base times height the base is 1, 2, 3, 4. And the height is 1, 2, 3, 4, 5. So the area of BSC equals 1/2 of 4 is 2. 2 times 5 is 10 units squared. Okay? And then now we're going to do this triangle. So the area of triangle ACT equals 1/2 base times height. The area of ACT equals 1/2. And this one, the base is -6 to 0, 0 to 5, that's 11, times the height, which is 4, or 5. So it's going from -4 to 1, which is a distance. So the area of ACT equals 1/2 of 55, which is 27.5 units squared. Okay, and I might have made a mistake up here, I'm thinking now. So, did I count correctly? This is -6 and 1 is 7. Yes, I did. This 6 right here should be a 7. 1/2 of 70 is 35. Okay, that's 35. Let me just erase that. Okay, I counted wrong. I thought this said 5. This is 6, and then 1 more. So this is 7, and the height was 10. So 1/2 of 70 is 35 units squared. Okay, so what we have just done was found the area of the entire triangle, the area of this green one, the area of the blue one, and the area of the purple one. The only thing left is this piece here. So if I take all of it, minus that, minus that, minus that, I'm left with the center piece. So the area of triangle ABC finally equals the whole thing minus the 3 triangles that are on the outside. So it's 110 minus the quantity 35 plus 10 plus 27. So the area of ABC equals 110 minus 35, 45, 55, 65, 72.5. So the area of triangle ABC equals 37.5 units squared. So that's this piece right in the middle here. Okay? Take the whole thing, subtract the 3 other triangles. That gives us the triangle in the middle that had no base or height. That was a straight vertical or horizontal, I should say. Okay, that is the end of lesson 19. Go do your problem set.